Hello, everyone. As sort of an introduction to predictive analytics, I wanted to go through a couple of fundamental issues, fundamental things about predictive analytics that I think will be helpful for you to know before you start reading the Siegel book. I think the Siegel book does a pretty good job of explaining sort of the kind of real world application of predictive analytics. But where I think he falls down a little bit is in the explanation of basic fundamental principles that are involved in predictive analytics. So that's why I want you to take a look at this presentation first, so that there's no question that you have a good understanding about how predictive analytics works and the very critical importance of using past or old data in order to be able to make predictions about future data. So when we talk about predictive analytics, we get back to the word prediction. And the prediction part of prediction sounds all mysterious, but it's not. There's actually more math and magic involved. So when we think of prediction, we think of looking into the future, but typically when we look into the future, there has to be some sort of a guide, otherwise we're just looking into a void. And so to get accurate results, we can't just look into the future without anything guiding us, and predictive analytics is no different. So the prediction in predictive analytics actually uses the past. It looks to the past and it looks to relationships in the past to make assumptions or estimates, or what now we're calling predictions, about likely future outcomes. So how does it work? Well, in its simplest form, we look at past data, things like sales records, medical records, sports records, etc. There's a whole bevy of sources of past records. And we make a determination about the relationship between potentially two variables or multiple variables. So in its simplest form, we're going to look at two variables. And we're looking at the relationship between those two variables as they were related in past data. And it could be things like age and sales. It could be weight and blood pressure. It could be home runs and the height of the player. It's just two things that probably had a relationship in the past. And now we're going to use that relationship to make projections into the future. So we look at these two variables in past data. We calculate the relationship between them. That's where the math part comes in. And then we use what we've learned about the relationship to predict what will happen in the future. So that's predictive analytics. And, as you can see, there's no magic to it. So there are two types of variables in predictive analytics. There's the predictor variable, also called the independent variable. And this is the variable that we have and are using to make predictions. There's also the predicted variable, and this is the output or the dependent variable, and this is the variable that we are going to be predicting. So in a simple linear regression, the value of the predictor variable can be used to estimate the value of the predicted variable. So let's look at an example. So imagine you've got customers that shop at Fred Meyer, and they use their loyalty cards or their loyalty numbers to get special deals. As you can well imagine, Fred Meyer tracks all of the things that each customer buys. But they also have information about their customers, like their birth date or something like that, and they can use the birth date to calculate the age of the customer. So then they might ask, is there a relationship between the age of the customer, which would in this case be the predictor variable, and the money that they'll spend maybe in a week or a month or a year, and that would be the predicted variable. So can we draw a linear relationship between those two variables? So, and if so, can we calculate this mathematical relationship? And if so, could we then say, can we use what we've learned to predict how much a 45-year-old will spend at Fred Meyer on average each month? And another really important part of predictive analytics is how accurate is our model? We can create a model between two variables, but if the relationship between those two variables is not linear or is not clean, then our model is not going to be very accurate. And we'll talk about that a lot more throughout the class. Here's another famous example, Dolbear's crickets. Amos Dolbear tracked, and this is back in the late 19th century, he tracked the chirps of crickets. So he would track the chirp of a single cricket, because of course you wouldn't be able to tell the difference of one cricket from another cricket when there's a whole bunch of them. So he tracked the chirp of a single cricket, and he was then able to listen to those and relate the number of chirps per minute to the temperature outside. It turns out that a cricket will chirp more when it's warmer. So he compared temperature and cricket chirps and was able to build a predictive model based on cricket chirps to tell how warm it was outside. There was enough of a linear relationship between those two variables in the sense that when one went up, the other one acted in a predictable and consistent manner. And that's what I mean by the linear relationship. So it's important to remember when we're talking about a linear relationship, we're talking about things that would be correlated or anti-correlated and things that would be predictable in a consistent pattern. One unit of increase will result in some measured amount of either increase or decrease in the other variable, but it's consistent and predictable. Here's the simplest of predictive analytics models. So we go through and we look at our old data, and we have known variable 1, which is our predictive variable, and we have known variable 2, which is our predicted variable. Okay. So we may have 500 or 5,000 or 10,000 or some number of records where we know the relationship between variable 1 and variable 2. We feed this into and create a predictive model. So what is known about the relationship between variable 1 and variable 2? Then we have two things that happen. First, we go into the future where we have data sets where we only have variable 1. So we know that variable 1, we know the value for variable 1, but we don't know the value for variable number 2. So what we're going to do then is we're going to take variable 1 and we're going to feed it into our model, and our model is going to allow us to output a predicted variable 2 that would be something we think is reasonably close, because now the relationship between the variable 1 and variable 2 in the future is being modeled on what we learned about it in the past. In Dolbear's model, we had old data. We had the temperature and cricket chirps. We created a model, and then in the future, he counts cricket chirps, and then he feeds that into his model, and his model will spit out what the predicted temperature is. So let's talk a little bit more about the old or the past data. So older past data, these are records that we're gathering every day, and they can be things like sales records, medical records, search engine results, or search engine, actually what you search for in a search engine. We can analyze this data to see if we can find meaningful relationships. We build our models that allow us to capitalize on these relationships, and then we apply these models to predict future behavior. A lot of what Siegel is going to talk about in a very, very long chapter 2 is things to do with privacy issues. So who is gathering your data? What are they using it for? Do you approve of this practice? And what do they know about you? So that'll be actually something that we talk about in some of the discussions that we have coming up. So there's a couple different ways that we can approach the past data for models. And there's really three main types of past data that we use to build predictive models. The first is a data set called training data. And this is used to train our model. You see train in quotes there, because it's really kind of a different use of the word train. It's basically how we look at the relationship between the predictor and the predicted variables and how we build our model based on that relationship. So we're using that training data to basically build our model, or what we say to train our model. We may have a set of data called validation data. And very often training data and validation data come in the same set. What we just do is we break out a portion of it for training and a portion of it for validation. And once we build our model, we might run that same model on our validation data just to make sure nothing looks weird or kind of strange, making sure that the model is accurate. We might also have a test data set, and the test data set is completely different from the training data and the validation data in the sense that it didn't come from the same source or didn't come at the same time. It's data that fits into the model, meaning that it has the predictor and the predicted variable, but it comes maybe from a different source or it's used in some different way. And this is just another way for us to test the model to make sure that we don't have any problems with the model. There's something we'll talk about this a little later, but there's something in predictive analytics called overfitting. And if we overfit our model to our training data, then quite often we'll get great results with the training data, but we'll get poor results with the validation data and even worse results with the test data. And that's the reason why we do the validation and test data in the first place, is to make sure that our model is not overtrained to the single data set for training, that it's actually more widely applicable. So why all the validation and testing? Well, because no model is going to be 100% accurate. They are estimations. They make guesses at what the predicted value is going to be. And they're going to have error. What do you mean by error? When we build the model, we use it to make predictions, but those are estimates. And we might be off from what the actual value turns out to be. So if we predict the amount of money that a 45-year-old is going to buy at Fred Meyer on a monthly basis, we might be pretty close to what it actually turns out to be, but we're going to be off by just a little bit. Sometimes we'll be off by a lot. It depends on how good the relationship is between our variables. So what we call the amount that we're off, what we call that is error. It's not really error in the sense that there's something wrong with the model. It's error in the sense that there's something different between the predicted value and the actual value. And the best models have little error. We'll look at ways to be able to determine how accurate a model is. But some models aren't so good, and they have a lot more error. So a common way to calculate error is to look back at past data. So we can apply the model that we created from our past data, we can actually apply it to the past data. Because remember, we had actuals and we had the actuals for both variables, the variable 1 and variable 2. So now what we're going to do is we're going to take variable 1, we're going to use it to predict variable 2 in the past data, and then we can check and see how different is the predictions that came out of our models from the actual values that were in the past data. And that will give us an idea of how accurate our model is. Another word for error is residuals. You will hear that a lot in predictive analytics when you see what are the residuals. It's basically a synonym for error. And the way that we're using the word error, residuals, is pretty much the same thing. So there's not really much different there. So later in the class, we'll talk in more detail about predictive models as you begin to build your own using Python. So we'll look at a couple different types of models. We'll look at linear models. When we look at linear models, we'll start looking at things called the intercept and the slope, and that'll become more clear to you as we work through the first build of linear models. We'll also show some application of linear models, and we'll also use logistic regression to predict the probability of an event occurring. So that's a little bit different. So basically the three models we're going to look at are going to be simple linear regression, where we use one variable to predict another variable. There will be multiple regression, where we use a combination of multiple variables to predict a single variable. And then there's logistic regression, where we use multiple variables to predict the likelihood on a scale of 0 to 1, with 0 being ain't going to happen and 1 being it's for sure going to happen. We use it to predict the likelihood of an outcome. But for now, let's talk about a complex regression model. And Zillow could be a great example of one. Zillow is the home valuation site where they take all kinds of different aspects having to do with a property, number of square feet, number of rooms, all kinds of things, age of house, neighborhood, amenities, that kind of thing. And they bring it all together and they use that information to predict the value of the home. They look at a lot of old data and their models are very well trained. And they can be fairly accurate with the predictions that they make. But what they're really doing is they're looking at, it's basically a predictive model, and gathering as much information as they can, building a very sophisticated predictive model based on a ton of old data that they've been able to gather, and then using that to make predictions. So this is more of a multiple regression model, and it's a much more complex model than we'll get into in this class. But it just gives you kind of a real-world application of somebody who's using this. And there's a lot of businesses out there that are using predictive analytics to try to make the best recommendations they can to their customers and to try to provide a competitive advantage to themselves. So just remember, when we talk about predictive analytics, we are selecting variables of interest. They can be predictive variables and predicted variables. We are looking at old data to see how those variables are related. We are building a model that is derived from the relationship between the predictor and the predicted variables in the old data. And then we're applying that model to new data. And that would be cases where we only have the predictor variables. So we can make an estimation about the predicted variable. So this will be kind of helpful for you to remember as you read through Siegel. One thing, like I said earlier in this video, one thing that he doesn't really do is he doesn't really kind of introduce the whole idea of how a model is built. And that's what I wanted to cover in this video. It's really important that you understand that it's collections of old data that allow us to look at the relationship between those variables and build that model in such a way that we can actually apply it to future data situations.